Hello guys, and welcome to this video explaining covalent bonding, which is chapter 8 section 1. Let's get started. So first thing we need to know here is why atoms bond. As you guys know, the important thing is to know the octet rule. So every atom wants to reach stability, and to become stable it should have 8 electrons in the outer shell. So each atom would like to have 8 electrons in its outermost shell to become stable. It can be achieved by either losing or gaining electrons, like we saw in ionic bonding, or by sharing electrons, which is done through covalent bonding. So every atom needs to have 8 electrons, which is the configuration of noble gases. As you can see here, noble gases, all of them have 8 valence electrons, with helium as an exception, which has 2. So this is octet rule. Now, covalent bonding, as a definition, it's the sharing of valence electrons. Pay attention to the word sharing. So there's no gain or loss of electrons. Where does it happen? As you can see here, covalent bonding happens between nonmetals, 2 nonmetals, or a metalloid and a nonmetal. So this is covalent bonding. Now ionic, as you recall, it happens between a metal and a nonmetal. So whenever you see metal plus nonmetal, you refer back to ionic bonding. In this chapter, you're going to cover bonding between 2 nonmetals or a metalloid and a nonmetal, which is covalent. The result is formation of a molecule when these combine, or these two. Types of covalent bonding, I think you already know these from previous years. First one is single, double, and triple. In single covalent bonds, you have sharing of how many electrons? 2. 1, 2. 2 electrons are shared. So this is called one pair of electrons. Every pair is equal to 2 electrons. In the double covalent bond, you have 4 total electrons that are being shared, so 2 pairs. How are they 4? Count them. 1, 2, 3, 4. 4 total electrons and 2 pairs. In triple bonds, you have sharing of 6 electrons in total, which is equivalent to 3 pairs of electrons. Every dash here is equivalent to 1 pair, which is 2 electrons. So in single, 2 electrons, double, 4 electrons, triple, 6 electrons. Now let's check how we can draw Lewis structures. Lewis structures are the drawings of the molecules, the covalent molecules. First part will be drawing diatomic molecules, ones that involve 2 atoms, like these: H2, F2, Cl2, I2, O2, N2. You have 4 steps. First, you need to know the valence electron for every atom. How do you know this? From the periodic table. Group 1, 1 valence. Group 2, 2 valence. Group 13, 3 valence. Group 14, 4 valence electrons. 15, 5 valence electrons. 16, 6 valence electrons. 17, 7 valence electrons. Group 18, no need to worry about these because they don't bond. Second step, draw the dot structure of each atom, the Lewis dot diagram, the one with the dots. Number 3, bond the single electrons together. Number 4, check if octet is achieved. Now to understand these steps, let's check an example. A really simple example is F2, fluorine. How many fluorines do you have here? 2 of them. 2 atoms of fluorine. So step 1, you determine the valence electrons. Each fluorine has 7 valence electrons. Why? Because fluorine in the periodic table is in group 17. Step 2, you draw the dot structure or the Lewis dot diagram for fluorine. Remember, you distribute these 7 valence electrons 1, 2, 3, 4, 5, 6, 7 all around fluorine. Now this electron, the one here, this is called the single electron or the bonding electron. These are 3 pairs of electrons that are lone pairs or non-bonding electrons. They don't bond in this case. So lone pairs cannot be shared. Only single electrons bond. Step 3. In step 3, you draw how many fluorines do you have? 2 of them. You draw them in such a way so that the single electrons are facing each other. Okay? Single electrons are facing each other. Then you just join them together to form this single covalent bond. So this is single. Why? You have sharing of 2 electrons, 1 from each fluorine, 1 single electron from each fluorine. Now let's count if octet is achieved. For each atom, we should have 8. For the first one, 1, 2, 3, 4, 5, 6, 7, 8. So 7 and 8 are shared. For this one, 1, 2, 3, 4, 5, 6, 7, 8. You can see the numbers here, the counting. Okay? So octet is achieved. What's octet? Each atom of these has 8 electrons in the outer shell. So this is how you draw Lewis structure. This is an example of single bond. Now let's take an example in which a double bond is used. The simplest example is oxygen O2. So first step, 2 atoms of oxygen. In which group in the periodic table is oxygen? It's in group 16. So each oxygen has 6 valence electrons. The dot structure of oxygen, you just draw it. You have 6 valence, 1, 2, 3, 4, 5, 6. Here you have 2 lone pairs. These do not bond. You have 2 single electrons. Now, these 2 single electrons can be shared. You draw 2 oxygens because you have 2 of them with the single electrons 1, 2 facing each other here. Okay? So, and then you connect them. You have sharing of 4 electrons in total. So 2 pairs. So this is a double bond. This is your double bond. 1 double covalent bond. You count the electrons for each oxygen. Of course, these are the lone pairs. You can draw them whichever direction you want. You can draw them. You can draw this one down or this one to the left. Doesn't matter. So you just count 1, 2, 3, 4, 5, 6, 7, 8. This is for the first oxygen. For the second oxygen, same thing. 1, 2, 3, 4, 5, 6, 7, 8. So each of these 2 oxygens has 8 electrons in the outer shell. Example 3, nitrogen. You do the same steps as fluorine and oxygen. This is the structure of nitrogen. You have 3 single electrons, total 5 valence. This is your lone pair, non-bonding. So you have sharing of 3 single electrons from each nitrogen. You just face them towards each other. Then you connect the 3 pairs. So then you count 1, 2, 3, 4, 5, 6, 7, 8 for the first nitrogen. 1, 2, 3, 4, 5, 6, 7, 8 for the second nitrogen. You have 1 triple covalent bond, and you have how many lone pairs? 2 1 first lone pair, 2 second lone pair. Octet is achieved in this case. Example 4, HCl. Now here you have different atoms. So hydrogen is in group 1, 1 valence. Cl is in group 17, 7 valence electrons. You draw the structure of Cl and hydrogen. This is your single electron and this is your single electron. You just put them facing each other. Then you connect the two electrons. Here you have one pair of electrons. This is your single covalent bond. Now, when counting octet here for chlorine, 1, 2, 3, 4, 5, 6, 7, 8, it has an octet, so it's stable. Hydrogen is an exception. Having 2 electrons is enough for hydrogen. 1, 2. It has achieved its duet, which is 2 electrons, and it's stable. So hydrogen is an exception. If it has achieved stability by having 2 electrons, then that's it. Now what about drawing Lewis structures for molecules which have 3 or more atoms connected together? The most important thing here, guys, is to know the central atom. Let's check an example. CF4. So here you have 5 total atoms. Carbon is in group 14, so it has 4 valence electrons. Fluorine is in group 17, so it has 7 valence electrons. Now, carbon, because it has 4 valence electrons, you draw it like this, it can bond from all sides. So this is your central atom, you put it at the center. Fluorine is terminal, you put it on the sides. Look at fluorine, it has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. How many bonds can each fluorine have? Only 1, because it has 1 single electron. What about carbon? It can have 4 single bonds. So you put carbon in the middle, 4 valence electrons around carbon, fluorine's terminals to the sides. This is your first bond between 2 electrons, 1 from carbon, 1 from fluorine. Second bond, third bond, fourth bond. Now how many bonds do you have here in this case? You have 4 single covalent bonds. And how many lone pairs do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 lone pairs. So in this case, octet is achieved. If you count for each atom, it has 8. Let's check just for carbon. 1, 2, 3, 4, 5, 6, 7, 8. Same thing for each fluorine. Another example, H2S, hydrogen group 1, 1 valence, sulfur group 16, 6 valence. As you can imagine here, sulfur is central and hydrogen are terminal. So this is your sulfur, 6 valence electrons, this is your hydrogen. You put sulfur in the middle, 2 single electrons for sulfur, which will bond each one of these with hydrogen. Now you can draw the molecule whichever way you want for now. You can put this hydrogen down and another hydrogen to the left, doesn't matter for now. So this is your molecule. Octet is achieved for sulfur, and hydrogen is an exception. It has 2. 1, 2, 1, 2. Sulfur, 1, 2, 3, 4, 5, 6, 7, 8. So this is your molecule. CO2, same thing, carbon in the middle, 2 oxygens to the side. Pay attention to the valence electrons. Here, because each of the oxygens has 2 single electrons, you will have a double bond. 2 from the carbon with 2 from the oxygen make up a double bond. And same thing to the left side, 2 from the carbon, 2 from the oxygen. These are the single electrons, they just bond. And you have 2 double covalent bonds. and you have 1 2 3 4 lone pairs. أعتقد is a cheap